Two blocks of equal mass are connected by a string that passes over a pulley, as shown in the figure. Block 1 hangs from the string, and block 2 can slide on a table. The system is released from rest. Using conservation of energy, a student derives an expression for the speed v of block 1 when it has fallen a distance h after the system has been released from rest, and obtains the equation v is equal to the square root of gh. The experiment is performed, and both h and v are measured. But the measured value of v is larger than the calculated value using the student's equation. Which of the following sources of experimental error could have caused the discrepancy? First of all, let me tell you that the correct answer is option E. We will examine each of the other options to determine why they are wrong. In the case of option A, friction between the table and block 2 is not negligible. Remember that friction is a non-conservative force, which is doing negative work on the system. Therefore, the blocks should end up with less speed than predicted, not more. For option B, the mass of block 2 is actually greater than the mass of block 1. Such a situation would mean that there is more inertia, which causes the system to accelerate less, not more. Therefore, the final speed will be less. In the case of option C, air resistance is not negligible. Once again, we are dealing with a non-conservative force doing negative work. The reasoning for option A is applicable also. The same is true for option D. There is friction between the rim of the pulley disc and the string. Finally, in the case of option E, if the table is not horizontal but somehow tilted to the right, then gravity will be doing work also on the block, which means the system will be decreasing more than expected in terms of potential energy and increasing more than expected in terms of kinetic energy. Therefore, that is the only reasonable answer.